you get there. Okay. This stuff basically stems from some very simple trigonometric properties. And most of these you guys already know. For example, we know cosine, sine, and tangent, correct? Now, I know that cosine, what's the reciprocal of cosine? Cosine is 1 over secant. Sine is what? 1 over cosecant. The reason why I write it as 1 over is because this is not reciprocal. If I reciprocal, then it becomes the original. Does that make sense? And then tangent is 1 over cotangent. Now this works the same way. Secant is 1 over cosine. Cosecant is 1 over sine. Cotangent is 1 over tangent. So basically you get the reciprocal functions like this. I wrote it out original way, this is the other way. Obviously you're just, if you think about it, these are just proportions. And you can switch things along diagonals and so it holds true because they're just ratios, really. So, excuse me. Again, let's write them here. So secant is 1 over cosine. With a lot of these things, you're going to see cosine of x, sine of x, thetas, all that kind of stuff thrown in there. This doesn't work unless they all have the same variable. In the grand scheme of things, for right now, when we're doing all this simplifying and verifying, you don't need to put the x there or the theta or anything like that. I can't have you do any of these problems if they happen to have an x and a y. It doesn't work. It's impossible. So as you've noticed, I just wrote cosecant or cosine secant. I'm just writing it just like that. So if you want to do that, that's fine. Not a big deal. When we come to use this stuff a little bit later on, in terms of equations, which we'll get to probably Thursday is my guess, we'll start with that. Then the theta stuff will come back, but they're not going to be as bogged down heavy as some of the things we'll look at to start. Okay? So far, so good? Okay. Now, these are your normal identities, how things move back and forth. The rest of them are what we call Pythagorean identities. Yes? Good old Pythagorean theorem comes back into play. But again, you guys know how this works because you've been doing this forever. For example, if I take and place a theta in the first quadrant. If I just place a theta there, what's my opposite? X or Y? Y, isn't it? Because that's your vertical. It says your Y. What's your Y value?
Positive.
Okay. What comes first in the alphabet, X or Y? So what? So it's what? Sine. Okay. Which means your adjacent's what? Cosine. Now, excuse me. Our radius for these guys was always 1, wasn't it? Okay. So if you think about it, what's the Pythagorean theorem for this?
Cosine squared plus sine squared equals 1.
Yep. There's your Pythagorean identity. Which therefore means if I wanted to get cosine by itself, what would I do? Subtract sine squared, right? So that means that cosine squared is 1 minus sine squared. And sine squared is 1 minus cosine squared. Be okay with that? Normally what you'll see is just the original part of that written out. They don't normally write out the other two. You can figure those out. So cosine squared plus sine squared is always 1. So far, so good? Okay. Let's take it a step further. What if I did, so we know this is true, cosine squared plus sine squared is 1. What if I divided everything by cosine squared? Because why wouldn't you, right?
Yeah.
What's cosine squared divided by cosine squared? Bless you. 1. Bless you. Ooh, here's a new one. What's sine over cosine? Tangent. It's tangent. Sine over cosine is correct. Sine over cosine is tangent. So sine squared over cosine squared is tangent squared. Did you forget that one? Excuse me. So we'll say tangent is also sine over cosine. That's y over x. Convenient how these things come back into play. So sine squared over cosine squared is tangent squared. What's 1 over cosine squared? Secant squared. Whoa. There's another identity. That's another Pythagorean identity. It just stemmed from the original. So the other one we have is 1 plus tangent squared is secant squared. Gee, I wonder what the other one is, how the other one is found.
You divide by sine.
You do the same thing. If I take the cosine squared sine squared, and I divide everything by sine squared, what's cosine squared over sine squared? Cotangent, correct. If it's reciprocal to there, it's got to be reciprocal to there. So there's cotangent squared plus 1 is cosecant squared. And then obviously you can move things around. Cotangent squared is cosecant squared minus 1. Tangent squared is secant squared minus 1, and so on. So we wind up with our, what do you call it? All these different identities. Okay? So what is all this stuff going to allow us to do? Well, all this stuff's going to allow us to do is to take and simplify a bunch of, basically it winds up simplifying a bunch of fractions. And depending upon what you get, what you start with, oops, right here, huh? Sine gerene over cosine gerene is. Shut up, Beanie. And then this one's always good. It's a little tacky for nowadays, but so I apologize. Oh, sorry to this.
Oh, Mr. Murphy, you can't.
I know it's not funny anymore, but
It's kind of funny.
it is. It was back in the day. Sine B over tangent B is cos B. Yeah, that's nowadays that doesn't look too good, so we're not going to use that one. So here's how this happens. A lot of these things are going to go from, we're going to take simple fractions, we're trying to figure out ways of rewriting. And what I'm trying to do today is give you guys a couple ideas on how to start these problems. Because more often than not, you guys are going to go, I don't know what to do, I don't know what to start. And usually what I would say is, suck it up, Buttercup, but then I would go into being nice. It sounded good at least. Anyway, so one of the first things I would look at is, if you have fractions, split them apart. Here's what I mean by that. If I write this as sine, isn't it the same thing as saying 1 over tangent? Splitting the fraction, that's what I mean by that, splitting up the fraction. Now, go looking, if you look at your list of things, 1 over tangent is what? Cotangent, okay? So what I'm trying to do is I'm trying to rewrite things, instead of reciprocals, rewrite them straight, because now, what's that? No, you do not, you do not. And then we know cotangent's what over what? Cosine over sine. Cotangent is.
Oh, yeah, okay.
So it's just sine squared.
Oh, I need sine squared. So let's solve this, right?
It's simplified. This is simplified. If it is verified, it'll show you what it has to be at the end. Okay? And I'll get to that. All right. So basically, what's happening is this is just a giant puzzle. Okay. It's a giant puzzle. You're just trying to use as many of these as you can to see where it leads you. Obviously, it takes a little time to get used to. You have never done this before. It's just a little getting started. Okay. So let's simplify. Another thing that'll happen a lot of times is if you're given stuff that are reciprocal functions, cotangent, secant, I would try to write them in terms of sines and cosines. Okay? So if I'm looking at that, cotangent, secant, they're next to each other means they're being multiplied. Cotangent we just did was what? Cosine over sine? Okay? So what I'm trying to do here is I'm just going to rewrite things in terms of sines and cosines. When I do that, it kind of, things might be able to start to simplify. Because what is secant? 1 over cosine. Oh, what happens? The rain, yes. No. What's my answer here? 1 over sine. Good. Remember, this sine is not wearing a life jacket. It cannot float up. Very good. So you get 1 over sine, which is what? It's kind of magic. All right.
So these x's.
You don't have to write them. Yeah, you're not solving for anything. There is no solve for anything here. Eventually, we will solve for the values, but we have to have a little bit of other things for it to happen.
Okay.
Right now, this is just simplifying. Like Sarah just asked, you don't have to write the x's. It doesn't make it. It's just more letters than we just. It's not a big deal. Okay. Next one, I have sine times the quantity 1 plus cotangent squared. So again, there's a couple of things you can do. You could distribute, or what's 1 plus cotangent squared? Takes a second to remember these things. Cosecant squared, okay? So if I did that, I get sine times cosecant squared. Cosecant squared is the reciprocal of what?
Sine.
Sine, very good. What's that? This is Pythagorean identity. Anytime I see 1 plus one of the things squared, I always want to check and see, is it one of my identities? Cotangent squared plus 1 is cosecant squared. Okay. So this same thing is saying sine times 1 over sine squared. Huh. Which is 1 over sine. Good. Because remember, this sine squared is just and this is cosecant. Not everything equals cosecant.
Everything equals
Okay. What's that? I did say that, but you're omitting a whole other parts. Yeah, right? Same idea. Cosecant tangent. Cosecant tangent. Again, when you see, one of the tips I'll always give you is try to always rewrite it in terms of sines and cosines if need be. Cosecant's the reciprocal of sine. So that's the same thing as saying 1 over sine. Okay. Tangent's 1 over what? Is cosine wearing a flotation device?
What if I draw?
It's fine.
What was that? Are you okay?
Oh, yeah. I just try to make you feel good about it for a little bit.
I feel really good about this.
Okay.
And then he crushes it.
Same idea. You'll see thetas. Theta is just same thing as an x or y, whatever. This says secant theta minus sine times tangent. Once again, my suggestion in this case was try to create fractions. Okay. Now, it's the same idea as saying rewrite things in terms of sines and cosines. So if I do that, see what happens. Secant's 1 over what? 1 over cosine, so I have 1 over cosine minus sine times sine over cosine. Now, when you're multiplying, let's just get that whole fraction for sine. So what's sine times sine?
Sine squared.
Sine squared. Do I have a common denominator? Yeah, so I can put it all together. So I have 1 minus sine squared over cosine.
That's
That's a thing, isn't it?
That's an identity.
It is an identity.
Oh my god.
Oh my god.
What is it?
Cosine squared.
It's cosine squared. Okay.
Oh my god, you can put that in there.
So you get cosine squared over cosine, otherwise known as? No. 1 minus sine squared. Remember, you can move these things around. 1 minus the sine squared is cosine squared. Cosine squared over cosine is just cosine. Yeah, but then you start looking for too much. But if you recognize the ones and minuses, that's when you look at the original and go, okay, that can even be. Okay. All right. Same idea. When you start seeing multiple parts, binomials, if you will, think about GCFs. When I look at that, secant squared minus cosine squared secant squared, well, I can do one of two things. If I take out a GCF, what do they have in common? Secant squared, right? Okay. So there's a couple of ways you can go about things like this. There's really no right way to start, or wrong way, I should say. So if I take out a secant squared, what am I left with? You probably could. What are you left with on the inside? Okay. Yep. Okay. What's 1 minus cosine squared? Sine squared. Everybody okay with that? All right. So now you have secant squared times sine squared. Secant squared is reciprocal of what? Cosine. Okay. So it's 1 over cosine squared. So that gives you 1 over cosine squared times sine squared. Isn't that sine squared over cosine squared? What's that? Very good. That's one way of going about it. Is there another way? No, how about this? Cosine squared and secant squared, aren't they reciprocals of one another? What happens if you multiply both reciprocals together? What do you always get? 1. Because if I do it this way, like I said, it depends on how you see it. You do secant squared minus cosine squared times 1 over cosine squared. That just becomes secant squared minus 1, which is? Guess again. What do you mean? Oh yeah. Yeah, think of this as I don't know, x squared minus 4x squared. Take out the x squared. You know what I mean? That kind of way. Remember, so if I move the 1, again, it's the same kind of idea. It really depends on how you see the problem to start with. There's nothing wrong with GCFs if you recognize you had reciprocals. If you rewrote everything in terms of sines and cosines, you might have seen this a little bit easier as well. It's totally up to you. Okay.
So you're gonna have to write down.
What you're doing right now is technically a trigonometric proof. You're using the identities to rewrite. Okay. It's proof-ish. Okay. So again, same idea. I have sine over cosine tangent. Now, see what my suggestion in this one was split the fraction. The only reason that I can do this is because it's multiplication in the denominator. Okay? If there was addition, I couldn't do this. So what this means is that I can rewrite this as sine over cosine times 1 over tangent. What's that? I'm sorry, what was the whole thing you said? No, because there's only one of them. So if there was two of them, then I would have had sine squared there. Does that make sense? Okay. What's sine over cosine? Tangent. So this becomes tangent times 1 over tangent, which is 1. All right. See, I think the next one's a verify. Nope. So I have sine plus cotangent times cosine. What do you think? What would you do first? Sines and cosines? Okay, cotangent's 1 over 1. Or in terms of sines and cosines, cosine over sine. Are we okay with that? So we have sine plus cosine over sine times cosine. Part on the right-hand side then becomes cosine squared over sine. In order to add fractions, what do you have to have? Common denominator. So, what do they need? What does the fraction on the left need, I should say? Sine. In order to add these things together, they need a common denominator of sine. Fraction on the left has a 1, so it needs to be multiplied by sine. So what's sine times sine? Fraction on the right has it. What's sine squared plus cosine squared? 1. Once again, not everything's cosine. It's a thing. It's Pythagorean identity. Actually, it's a Pythagorean theorem. Good times, huh? Take a sec. You could foil? Yeah, it's not sine squared, it's just 1 minus cosine, so you gotta be careful with a lot of this. Oh, really? So, there's a couple of things you can do, all right? Here, if I FOIL the stuff out, when you FOIL, remember what does it stand for again?
First outside, inside.
All right, so if we do that, we get what? Cosecant minus cosine cosecant plus cotangent minus cotangent cosine. Oops. Cosine. So far, so good? All right. Now, rewrite everything in terms of sines and cosines. It's always a good thing to check to see what happens. Okay? So I have 1 over sine minus cosine over sine. You okay with that one? I'd just split them together. Plus cotangents, cosine over sine. And then minus cosine over sine times cosine. So far, so good?
Where did you get the last time?
Cotangent. The cotangent is known as cosine over sine. Okay. What happens to those middle terms? They disappear. They're gone. Minus cosine over sine plus cosine over sine. Sine are us, suckers. Yikes. 1 over sine minus cosine squared over sine. Huh. Do they have a common denominator? You can rewrite. They have a common denominator, so you get 1 minus cosine squared. That sounds like that should be a thing. It's sine squared. Good. So you have sine squared, which is, you opened up the door. Oh, his eyes. I thought it was cool. Yeah. Sorry, I've got that stuck in your head now. Oh, ace of base, right?
Mr. Burko, give me $10 to get another ace of base class. He wins.
I'm having flashbacks to college trying to remember, because I know that there was another one. There was another popular one. Song.
Yeah, but you can't look it up.
Yeah, see, that's. Yes, sir.
I'm confused on like the 1 minus cosine squared equals sine squared. Like, how does that?
If I move cosine, I get 1 minus cosine squared.
I just trying to figure out how it all arranges.
All right. Secant squared minus tangent squared. Sorry, I had a question.
I just saw something here.
No. Again, how did you figure that out so fast?
Because of what?
She did the same.
She did the thing, and the thing was right.
Oh, who's on? Wait, hold on. Stop.
If I move tangent. Now, here's the thing. Let's say you didn't realize that. You won't cry because secant squared is 1 over cosine squared, correct? Tangent squared is is sine squared over cosine squared. What's common denominator, right? Okay. So 1 minus sine squared over cosine squared. What's 1 minus sine squared? Cosine squared. Therefore, what's cosine squared over cosine squared? 1. You'll still get there. Yeah. All right. Verify. Verify is a little bit different because it tells you what it has to equal when you're done. Okay. I think that verifies are easier because you have the answer. So the problem is that when you guys do these things, you'll just make up a bunch of crap and hope it sticks to the wall and it works. And
So it's just like going with does and does.
yes, yep, pretty much. So the idea is you have to show how it gets there. So when it goes through these things, same rules, same things apply. You have cosine times secant equals 1. Well, that's a really easy thing to verify because what is secant? form cosine. And you just go, na, 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 and you're done. Okay. It is very rare that you're usually going to go from left to right, make the left look like the right. It is very, very rare we go right to left on these things. Okay. I think I have maybe 2 or 3 total that I'll actually tell you go right to left, or I'll just rewrite it. Honestly, you just flip the way you write it down, so it's not a big deal. Same thing. Tangent, cosecant, cosine equals 1. When you see all of that, always try to go and rewrite things in terms of sines and cosines. Anytime you have tangents and reciprocal functions, try to write sines and cosines, but especially when they're being multiplied, because a lot of times you get some going on. All right? Tangents, 1 over what? All right, so we have sine over cosine. Cosecants, 1 over what? And cosine over 1. All right. Ready? Yep. And remember, it's not solving it. You're not solving for x. You're just showing that it works. Okay? Yes. Here's the trick. When you start with a fraction and you end with subtraction or your addition, or you wind up or you start with a fraction and then all of a sudden you wind up with 2 terms, that meant they probably had to get a common denominator. Okay? They probably had a common denominator. So, in order for us to get some sort of a common denominator to make this work, cotangent squared is what over what? Or, better yet, cotangent squared is an identity. Cotangent squared is cosecant squared minus 1. The idea here is that by switching this into 2 parts, it's going to maybe get me somewhere. So that was cosecant squared minus 1 over cosecant. Remember earlier? Split the fraction. It's got a common denominator, so write it as 2. What's cosecant squared over cosecant? Cosecant. What's 1 minus cosecant? Oh, I'm sorry, what's 1 over cosecant, excuse me. Sine. Yes.
So you can have the same denominator when there's only one denominator.
Yeah.
Only
Yep.
one numerator when
Yep. That's how denominators work. We're doing time. Doing all right. Okay. Sine over 1 minus cosine. And I want it to equal 1 plus cosine over sine. What's that? You're almost there.
Wait, is it something like?
Ah, but we made that squared.
Oh, we can.
All right. Do you remember conjugates?
Are we not having that? What is it?
Remember, we had you were creating a difference of squares. We did this. Anytime with imaginary numbers, we did this with roots.
Oh, yes.
What's 1 plus cosine divided by 1 plus cosine? 1. I'm just multiplying by a crazy factor of 1. Okay. So what I'm creating here is I'm creating a difference of squares. If I FOILed out this denominator, I get 1 minus cosine squared, right? All right. Numerator, just multiply across. Sine plus sine cosine. So far, so good? What's 1 minus cosine squared?
That one's sine squared.
Huh. Common, they have that in the GCF there, don't they? They both share a sign. I take a sign out. We're almost done.
When?
Stop.
Okay. Oh, that's all right.
Yep. Unfoil it, if you will. Undistribute. What can you knock out? Yeah. No.
But I feel like
Everything else.
Not that bad.
Fun for you. That was
Okay. This is a simplifier. The reason why it's a simplifier is because there's no equal sign. That's telling you what you should wind up with. Notice, this one should be pretty easy. If you look at that numerator, isn't that just create difference of squares? Just get secant squared minus 1, right? What's secant squared minus 1? Which gives you? This is really old textbook stuff here. All right. Now, in this one here, oh, you want that quiz thing, don't you? Yeah, give me a second. What's the 639 side? You should be able to get all of those without a problem. Most of them are kind of the same thing over and over again. What's that? Yeah, the ones I'm looking at the ones on the bottom there. The complexity of the ones on the bottom are pretty straightforward. What I'd like you guys to definitely try though, I want you to also try out 31 through 38. We'll get into some of the other more difficult ones afterwards, but you should be able to knock out, for what we've just gone through, that first chunk of that 1 through 18 should be easy. The 31 through 38 with the verify, those can get a little tricky, but remember, you want to try to rewrite things in terms of sines and cosines, distribute a lot of stuff, use reciprocals, and go for it. All right, give those a shot. Yep. I hope. And then we'll get more difficult because that's what we do. Crush the souls of the young.
I don't want to talk to you. I don't want to talk to you. Any bad or
that missed the quiz stuff out on Friday, I want you guys to see this stuff because this is hard quick here. You guys will just do your quiz junk tomorrow.